This is exercise 25.30. So they give us a circuit, which I'll show in a second, two batteries, some resistance, resistors, everything. Ask us to find the magnitude of the current, the direction of the current, the voltage, like AB at the 16-volt battery, and then the potential difference, AC, of point A with respect to point C. Very specific. So here is the battery it gives us. So A is finding that magnitude. So magnitude of the current. So B equals IR, and this has the current. And because the things we have in here, the ohm signs are, are nice resistances, and then these are voltages. So the only thing we have left in this equation is actually the current. So we're going to use this, but we're going to have to go around the circuit. So to do this, we're going to just pick a direction. It doesn't matter which direction. If you end up being wrong, your math will tell you later, and then you just switch it like negatively. So it doesn't make a difference. We're going to go counterclockwise because I think that's just easier. So I'm going to start right here at the 16-volt battery, because batteries go out in the direction of the positive. So it's going this way, whereas the 8-volt would be going this way, which I'm going counterclockwise, so that doesn't work. So we're starting at the 16-volt. So that is the positive volt. Now, obviously, if we're adding up voltages, I should say that. So we're starting with 16-volt. Now, voltage is also equal to IR. So I is going to be, we have one big I here, but this is a resistors. So resistors take away, so we're going to subtract it. So I, and then we're going to have all the resistances in this entire thing. That's plus sign. 0.4. Great. And then we have this voltage. However, this voltage is negative because, like I said, this 8 voltage wants to point clockwise, and we're going counterclockwise, so that is actually negative to our goal. And then this is 0, right? Because we want it to be constant. We're a stable circuit. So then you basically have to find, A, just solve it. You have everything else, or I, not A, but is an ampere. So that is A, which, go ahead and solve that out, and you get 0.4706 for the long number of amperes. And this number is positive, which tells us that that initial direction we chose is correct. So B is counterclockwise. If you initially chose to go clockwise, you would have gotten this exact same number, but negative. And then if it's negative, it tells you that you need to be going in the other direction. All right, so C is find the terminal voltage VAB of the 16-volt battery. So that's, of course, this top battery right here. Yeah, right there. And so VAB, we know that's like VB minus VA, but it also has this nice equation of this. So we have E in this case is not like energy, but it's the same thing, it's the exact same thing as voltage for this battery. So it's 16 volts minus I, which we just found ever so nicely, and then times R inside that battery is 1.6. That's the whole thing, 15.2 volts. Okay, D is a little bit more difficult, very similar. Find the potential difference VAC of point A with respect to point C. So VAC, we still have this equation that we just used, but we have to make some changes. So AB, you can see that's going B to A. This is in the direction counterclockwise. However, AC, if we're going clockwise, that's one thing. Not clockwise, but the direction of our motion. So technically, with AC, you're supposed to go C to A, just how in VAB we went B to A. So going B went A like this, we went through our motion. So we're going to go through our motion this way. You can also go backwards from C to A if you want to do that, but you just have to change the sign of it. We are going to go our normal direction. So E is 16, and then minus, you have your I, 0.4706, but R, we have two different resistances here. You can see. So the only voltage in this whole thing is 16 from going to from C to A this way. We pass a voltage of 16 and we pass the resistances of 9 and 1.6. So that's how we get that. And you get 11 volts. Now, like I said, you can also go the opposite direction. As in, you can go C to A in this way. But in order to do this, you have to change the signs. So normally, when you're adding up the 8 voltage in our counterclockwise, you say this is negative. But since you're switching directions, you actually have to say that is a positive. And also, you know how you normally remove, like subtract all the resistances? Now you have to add them. And we are going to have different resistances on this path. We're going to have 1.4 and 5. But you can go ahead and solve that and you are still going to get 11 volts. So this just shows you that either way you go, you should get the exact same thing. You just have to keep in mind that if you're going counter the direction of current, you do have to change your signs on the direction you're going, of course, because you're technically going backwards the current. So there's that.